Hello.
Hello, sir.
Yeah, good evening. How are you, Charan?
Fine, sir.
Right. Okay, everybody joined. What happened, Mrinal? Last class, yesterday you were not there.
I was there, sir.
Last class, yesterday.
Yes, sir.
Okay, did you join it
Sunday.
late yesterday? Yes, yes.
Yesterday was Sunday, no? There is no class in Sunday.
Sunday morning class
Oh,
is there, na?
yeah.
9 to 10.
There was, sir. I slept, I slept, sir. Sorry, sir.
Okay.
You shared the notes, no, sir, of yesterday's
Yes,
class?
yes, yes.
We
Okay.
did only, uh,
Electric
that's,
flux part we did.
no, sir.
Okay.
Then you didn't share that electric flux part.
No, no, just check it. It's there. Electricity class, no? See that?
Oh, yeah.
Yesterday
I was
is there.
seeing mechanics. Okay, okay. Yes, sir.
Okay.
Okay.
Chili, let's start now. Okay. And Lokesh, how are
Okay,
you?
fine,
Good?
sir. Yes, sir.
All right. Okay. So this is where we were, na? We were discussing about the motion under the gravity, okay? So time of flight is there, isn't it? What is the maximum height reached by the particle in the motion under gravity? That is what we have discussed, right? Time it reach. Now, let's discuss a few more example on that. Okay. Here we have thrown the particle from the ground and the particle is again coming back to the same level. Na? Now there will be some cases where particle is thrown from some height. Okay. And then particle will reach the ground. So let's discuss that question. Here what has been given. A particle is thrown from a height of 100 meter, okay, upward with a velocity of how much? 20 meter per second. So what will happen? Tell me. Will it first rise a little bit up and then what will happen? It will reach the ground, isn't it? Then it will what? Reach the ground. So here we have to find out few things. First thing, find it. Time of flight. Okay. First one is what? The time of flight. Time of flight means what? Total time taken by particle to reach the ground. Second thing, velocity at the time of reaching the ground. Okay. Velocity at the time of reaching the ground. Let's find out these two things. Okay. Okay. Chili, please tell me what is going to be. Please tell me what we should do it.
Sir, we can calculate the time of ascent and time of descent from that point, and then since the velocity will be same when it comes back down at that point, we can again take it as from that point to ground is equal to.
Yes. Yeah, that we can do it, or we can directly also calculate it, na, directly from the initial point and final point. Please tell me, can we take it? This is my initial point and this is my final point. Why?
Mm,
Because when we are applying the equation, we are going to write it what? Displacement,
it's,
velocity, these things.
yes, sir. So it's gonna cancel.
So if I'm writing displacement velocity, so it doesn't depend on the path. We just need what? Initial and final point. Okay. And which direction you are taking positive? Upward or downward?
Upwards, sir.
Okay, let's take it upward as what? The positive. So tell me, what is the displacement? Can I use it if I want to know the time? Can I use the equation S equal to ut plus half at square? Please tell me. Here I cannot apply direct time of flight formula है ना, because time of flight formula was for particle projected from ground and again coming back to the ground, but this is not particle
Q by
projected
2G.
from the right. That case we can use it, but here we cannot use that formula, isn't it? Because here particle is thrown from some height and then it is coming to the ground. Okay, so but equation of motion is always applicable na? Equation of motion is always applicable whenever we have the constant acceleration. So please tell me, what is the displacement of particle? Can you tell me what is displacement of particle?
minus 100 meter.
Yes, very good, that is minus 100 meter. Okay, because the displacement is downward direction. This is your initial point, this is your final point. So initial to final, if you join it, it will become downward. So that's why minus. Now initial velocity is what? Is it plus 20t? Plus
Yes.
half. Is the acceleration is minus 10 to t
Yes, sir.
square. So now we have a quadratic. Let's solve this quadratic and we'll get the time taken to reach the ground. Okay. So what is this quadratic? 5t square minus 20t minus 100 equal to what? 0. So we have t square minus 4t minus 20 equal to 0. So what is the t we are getting? Minus of minus 4 plus minus b square, that means 16, 4ac, right? 4ac means 80, isn't it? Divided by 2 into a. So if we simplify, what we are getting? 4 plus minus root 96, isn't it? Root 96 is the root 96 is 24 into 4, है ना?
Yes, sir.
So write it or 16 into 6 we can write it. So 4 root 6 will come, है ना? 4 root 6 by 2 will come. So we are getting 2 time. One time is 2 plus 2 root 6 and other time is 2 minus 2 root 6. That is not possible na? Because it is coming negative. So that means what is the correct time taken by the particle to reach the ground? So time taken by particle to reach the ground is what? 2 plus 2 root 6. Okay. And if I'm asking what is the velocity at the time of reaching the ground, so should I apply the equation v equal to u plus at? Please tell me. Or
Yes.
v square minus u square equal to 2as also we can use it. Hai na?
Since you not it will become easy.
Right. How much it will come? V equal to what is initial velocity? Plus 20. What is the acceleration? Minus 10. And what is the time? 2 plus 2 root 6 we have. So 20 get cancelled out. Is it coming minus 20 root 6 meter per second? So what is this minus representing? This minus is representing that when this particle is about to reach the ground, its velocity is in the downward direction. Is that clear?
Yes, sir.
Now, this is the case 1, okay? Just second case what I am giving to you from the same height, same tower, 100 meter above. And this time I am not throwing upward with 20 meter per second. I am throwing what? Downward with 20 meter per second. Do you understand the question?
Yes, sir.
Please tell me. Understood the question? This
Yes,
time
sir.
what we are doing, instead of throwing up in the second case, what I'm doing in the second case, instead of throwing up, we are going to throw the particle downward with 20 meter per second. Can you tell me how much time it will take? Will it take same time or different time?
Different time.
Different time. Can you calculate that one? So should we apply the same equation of motion one more time? And again, two things you have to calculate it. First one is what? What is the time taken to reach the ground? And the second one is what? What is the velocity at the time of reaching the ground? Okay. These two things again we need to calculate it. So please tell me how much it will come in the second case. There are two ways you can solve it. One is by applying the equation of motion you can solve it. Or other one is what? Can you tell me what is the other one? There are two methods to solve the second case. What are the two methods? Let me tell you one method. Okay, first, in the second case, what I'm going to do it. In the second case, can I write again the same equation I am going to use it? S equal to ut plus half at square. Displacement will be minus 100. Initial velocity, how much it will be now? Please tell me. In the second case, what will be initial velocity? Plus 20 or minus 20?
Minus 20.
Minus 20, because it is in the downward direction. So it will be minus 20 into t half. Acceleration is downward direction into t square. This is again a quadratic, and we can solve this quadratic. What we will get it? 5t square plus 20t minus 100 equal to 0. 5 you can take it common. So it is coming t square plus 4t minus 20 equal to 0. If you calculate t, it is coming minus 4 plus minus root 96 by 2 into a. So that is coming minus 4 plus 4 root 6 by 2, and another one is coming minus 4 minus 4 root 6 by 2. Again, that is negative, not possible. So what will be our correct answer? Is our correct answer
Root
is
6 minus 4 by 2. 2 root 6 minus 2.
2 root 6 minus 2. Understood? And if you calculate the velocity, just check it what you are getting. V equal to, what is u? Minus 20. What is the acceleration? Minus 10. What is the time? 2 root 6 minus 2. Am I getting again minus 20 root 6? So that means, can I say at the time of reaching the ground, its velocity is 20 root 6 meter per second. In which direction? In the downward direction. Is that clear?
Yes, sir.
Please tell all of you, are you
Yes, sir.
clear about this second part of the question?
Yes, sir.
Now tell me, what is the other method I could have followed to solve this question? Look at the case 1 and tell me. Looking at the case 1, can you tell me there is another method possible to solve this question? Tell me. Case 1, look at that. In the case 1, whatever time came, right? And case 2, see, is the case 2 time is what? Total time of case 1
Minus time of flight.
minus whatever time is for this journey. Please tell me.
Yes,
Please
sir.
tell me. Second case time, is it the, what is the total time of the case 1 minus this dotted portion I have done it? Please tell me. Please tell. Is this part clear to you?
Yes, sir.
So you could have solved it by that method also. Matlab, we already know what is the time taken in the first case. From that, if you would have subtracted 2u by g, you would have got directly the answer of the second case. Okay. Now the third case. Okay. Third case, what we have, please tell me this time what I'm going to do it. From the same tower, same height. Now I am just going to drop a particle. Drop a particle means what? Initial velocity 0.
0.
Tell me how much time it take to reach the ground. How much time it will take to reach the ground? Please tell me. Height is same. Tower height is same. Can you answer it?
2 root 5.
2 root 5. How are you answering that? Did you calculate or something else?
Calculated on this. Or we can use root 2gh.
Calculated?
G. Root 2h by g.
You know this thing? Please tell me. What is that? See. First case, from a fixed height. This is applicable for any case, okay? From a certain height, if you throw a ball up, with some velocity, it takes t1 time to reach the ground. From the same height, we have thrown with same velocity downward a ball and it took t2 time to reach the ground. Then, if I try to calculate from the same height, if I just drop the ball, then you know how much time it will take to reach the ground? Under root of t1, t2 time. Understood? You can calculate it. What is the t1? What is the t1? 2 plus 2 root 6. What is the t2? 2 root 6 minus 2. You know what is the time in the third case will come? What is the time in third case will come? It will come under root of. Third case, what is the time will come? What is the t1? 2 root 6 plus 2, na? 2 root 6 plus 2. And the second case, it is 2 root 6 minus 2. That is the time in the third case. This is directly from the formula. You can also solve it and get the answer. So tell me how much is coming. Is it coming 4 into 6? Is it 24 minus 4? Is it 20? 2 root 5. Second, we got it. Huh? Let's see with the help of equation. With the help of equation, what is the displacement? Minus 100. Initial velocity 0t. Half acceleration is minus 10 into t square. Is the time is coming 2 root 5 second? Please tell me. Please tell. Is that part clear? So please keep in mind anywhere you got the question in the form of symbols. What is the symbol? But what is important to keep in mind here? Here, whatever is the initial velocity, same here is the initial velocity. One case upward direction, one case downward direction. And height of the tower is what? Same in all three cases. Understand? The first two case, if the time comes t1 and t2, then the third case, the time will come how much? Under root of t1, t2. So please tell me, do you understand how to apply this equation of motion in the motion under gravity?
So in AP exam, they'll give like this follow-ups, or will they give it separately?
Yeah, it may come. No. We are just discussing this one so that you will understand all the cases. When we should write it something positive, when we should write it negative. In your exam, maybe only one part of the question will come. Maybe only this one will come. Or maybe only this part will come. Or maybe only this part will come. Or maybe sometime they will ask you to calculate T1, T2. Tell me what is the ratio of T1, T2 coming to us. Isn't it? So any
So should we
portion of
write
the
in
question will come.
should we write in statements,
Yeah,
sir?
please.
Something like in FRQs,
No.
should we write statements, sir?
Where?
In FRQs, sir. Free response questions, sir.
Okay. There you have to write it in complete detail, na?
Like statements also should we write,
All
sir?
this. Yeah, I think that is the pattern here. If we discuss the, it is given, na? Response question, everything you need to mention it in the question, na? Right? Please tell me, is this part clear?
Yes, sir.
Please tell. Clear this part.
Yes, sir.
Actually. So let's discuss the next part now. Here, let's take an example. In this example, I'm going to first solve this example with the help of what? The normal motion, okay? And next I will solve this example with the relative motion also, okay? Reference frame is there na, in the question. Different reference frame is there in the question, right? Relative motion we have. So we'll solve the same question with the help of what? The relative motion also, okay? Question gave what? Ball is dropped. Ball is dropped. Ball is what? Dropped. And the ball B is what? Thrown with a velocity of height is Let's take it again 100 meter. Okay. Okay, clear. Now what happened? This ball B is thrown with what velocity? Meter per second. And they are both moving along the same straight line. They are both moving along the same straight line. Okay. We have to find the time of collision. Understood? What is they are asking? Find where they will meet. We'll write it like this. Will meet or find time of collision. Okay. That is part of the question. And the second part of the question. Second part of the question we have to write the velocity of the particle at time of collision. Velocity of particle at the time of collision. That is the second. And third thing is also find out where is from the ground also you can answer me. From the top of the tower also you can answer me. Okay? Anyone. Okay? So place of collision. Where collision, where these two particles. Okay? Okay. I think that this will be the same. No. Please me all of you. I think that is going to ask in the same. Ask you one part of the question. If it is a single choice question, they will only ask you let's collision, or they will ask you velocity at the time of collision. Okay, or where they have collided. Okay. If it is a single choice question. But we have in the single choice two type of questions. Multiple choice is also there, right? Please check it. That is what I saw it in the pattern. The recent pattern, the single choice and multiple choice, isn't it? So if multiple choice is there, then the two variables can be asked in the question. Please tell me, clear?
Yes,
Hello.
sir.
So
Yes.
please tell me. But we are learning here the question. Every time if in a question, two things can be asked. We should learn all those two, three things in the question. Okay. I will share the complete. Do you have that PDF with you, which I have shown it last day? Syllabus, exam pattern, everything.
Yes, sir. Yes, sir. From college, board, no, sir.
Yes, exactly the same one. I am also
Yes.
following the same one. Right, there is everything in detail given there in the exam pattern, syllabus, topics, subtopic. Everything is given in that one. Okay. So
Okay,
please
sir.
tell me what will be time of collision? Can you tell me? What will be time of collision? Here I am not solving with the relative motion because I have not yet discussed. But later you will see that I will solve the same question using the relative motion also. We can solve the same question using what? Relative motion also. So please tell me what will happen at the time of collision? Can you answer it? What will happen at the time of collision? Can I say at the time of collision, this ball must have reached somewhere here and the ball B
Velocities will be equal.
must have reached somewhere here, isn't it? So
Yes, sir.
this is the place collide, na? So collision means what? Whatever the time has traveled, can I say that B has also traveled for the same time and they reach the same point? Then only they are going to collide.
Time will.
Then only they are going to collide.
Yes, sir.
So what I am going to assume, let's say they are going to collide at some x distance. So that means what will be displacement of A? Is the displacement of A is going to be x and for B it is going to be 100 minus x. Chaliye, tell me what is the displacement of A? I should write it. Which direction you want to write it positive? Upward. So please tell me what is the displacement of A? Plus x or minus x?
-6.
-6. Initial velocity of A, 0t, half. Acceleration of A, -10 into t square. That is the first equation. What is the displacement of B? Is the displacement of B is in the upward direction? Look at the initial point and final point for the B. So upward direction. So that means what will be displacement? Is the displacement is going to be positive for that initial velocity plus 50. Time is what? Plus half square. That is the second equation. Now with the help of these two equations, can we calculate x and t? Look at that. Please tell me, with the help of equation 1 and 2, can we calculate x and t? So, if we want to calculate x and t, should I subtract equation 1 and 2? That equation 2 and equation 1 can be subtracted. If we subtract it, what will happen? 100 minus x. So, x get cancelled out. We have 100 equal. Is it coming 50? And see that minus half into 10 into t square and minus half into 10 into t square. That's what? So it means what is the time of collision coming? 2 seconds coming to us. Understand what is the time of collision? 2
2
seconds.
seconds.
So they are going to collide at t equal to 2 seconds. So where they will collide? So now I will equation 1 and equation 2. Okay. So equation 1 if I'm using, to what I'm getting? Minus x equal to half minus 10 into t square. Is the x is coming 20 meter for us? Please tell me.
Yes, sir.
So that particle A will travel how much distance? 20 meter. And particle B will travel how much distance? 100 minus x. That means 80 meters, isn't it? That means B has reached here, right? B has reached here and A has reached here, and they are going to collide. What is that distance? After calculation, we came to know that A has traveled 20 meter and B has traveled 80 meter. Can we also find out what is the velocity of A and velocity of B at the time of collision? So velocity of A, will it be equal to u plus acceleration into time minus 20 meter per second? Minus is representing that A velocity is downward direction at the time of collision. And for B velocity, if I calculate it, so u plus acceleration into t. So B velocity is plus 30 meter per second. But at the time of collision, A velocity is what? A velocity is downward direction 20 meter per second and B velocity is upward direction with what? 30 meter per second. Now we can mix this question with the collision also. Center of mass and collision. That if it is a perfect elastic collision, what will be their velocity after the collision? If it is perfect inelastic collision, what will be the velocity after the collision? Okay. So as gradually we will move to next chapter, these things we are going to use it in those questions, in those chapters. So please tell me, is the equation application part is done? All of you understand how to apply the equation?
Yes, sir. Sir, and in the exams, mixed concepts also will come.
In the yes, maybe some questions will be there. Yeah. That's why we are discussing all these questions, na? Okay.
Yes, sir.
But not all of there will be few questions that it's like that that all the question next one, but you should prepare for all the possibility. Please directly formula is what motion and gravity is the formula is, 2u by z is the time of flight, c is the height, and time of ascent, time of descent. So questions won't only come on these 3-4 formula, na? That's why let's prepare for all the possibility, okay? So that any type of question comes and you will be able to answer it. Okay? Isn't it? Please tell me. What is the purpose of this class? To prepare for all the possibility, na?
Yes, sir.
Please tell all of you. Hmm?
Yes, sir.
Right. Last question on this one. There is another type of question. Sometimes they will give you. Now, sometimes they will give you a hot air balloon is there. Balloon. You know balloon? When you cut the thread, what will happen? It will start rising, isn't it? So, in the question gave what? A hot air balloon is there, something like this. Initially, it is at the ground. This balloon start accelerating upward with some acceleration 4 meter per second square. Initially, the balloon is what? At rest. What happened? This balloon will start rising. Na? This balloon will start rising up, and after some time, balloon will acquire some velocity also, isn't it? What did they say? Once this balloon accelerate for what? Let's say 5 second. Okay, 5 second, or let's say, chalo, let's take it. This is the balloon situation at t equal to 0. They are saying at t equal to 5 second, a small stone is dropped from that, or a food packet is dropped from that. So what will happen? Can you tell me how the journey of the food packet will look like? It is dropped from something moving, right? Whenever we drop any object from someone moving, what will be the initial velocity of that dropped object? Can you tell me what will be the initial velocity of that dropped object?
The velocity of the container, what is called?
Yes, velocity of the moving container or moving medium from which it is being dropped. And that is because of what? That is because of the inertia of the motion, isn't it? If you are sitting in any car or any vehicle, right? When you come out of it suddenly, what is your velocity? Isn't it your velocity is just as same as the velocity of that moving train or car? That's why it is said na, that let the train or vehicle to completely stop before getting down. Understood? So whenever they will say a stone or a particle is dropped from this moving balloon, that means what? The velocity of that object will be how much? Velocity of that object will be same as the velocity of that balloon. Understood? So now once it will come out, whatever is the velocity of the balloon at this moment, can I say, and keep in mind, velocity is exactly same, not the speed. If the balloon is going up, the object which comes out of it, that will also have upward velocity. If balloon is going down, the outcoming object will have downward velocity. Clear? So it means if I say t equal to 5, a particle is dropped from it, and now the question asks, find what they are asking in the question, find time taken by stone. Okay, what are they asking in the question? Time taken by a stone to reach the ground. Time taken by a stone to reach the ground. Understand the question? So I could have directly given you the velocity of a stone and I could have given you the height from which it is projected, which I have done it in the last few questions. This time I did not give you what is the velocity of this one. So how do I calculate it? And from what height this stone is dropped? That is also not given. How can I get these two things? So to get these two things, should I take help of the balloon? Please tell me. Should I take help of the balloon? Please tell me. So for balloon, tell me what equation I should write it. Can I write it for the balloon? V equal to U plus AT, I should use it. For the balloon, should I use it? V equal to U plus AT. Initial velocity of balloon, 0. Acceleration of balloon upward is there, so plus 4. Time is 5 seconds. So tell me, what is the velocity of the balloon? 20 meter per second. So can you tell me what is the velocity of the stone coming out of it? Can I say velocity of a stone coming out will be also 20 meter per second in the upward direction? Please tell. Is that part clear? Next thing,
Yes, sir.
where the stone come out? That means I need to know where was the balloon when the stone came out. So how do I calculate that one? Should I use it S equal to ut plus half at square? I'm still using for the balloon because I need h and v. I need the height from which the stone is dropped, and I need what velocity stone is dropped. So for that I'm taking help of the balloon. Okay. So u into S equal to ut plus half at square. U is 0. So into t half. Acceleration getting 25 into 4. 100 by 2. 50 meter I am getting. That means is the stone is dropped from a height of 50 meter. At the moment you understand these two things, has it become the same question which I have discussed here with you? A stone is thrown with 20 meter per second from a height of 100 meter. Has it become the same question? Please tell me. What is this question? A stone is dropped from a height of 50 meter, right? With what initial velocity? 20 meter per second upward. Now tell me how much time the stone will take to reach the ground. So now I will take help of what? Stone. Understood? Now what we will do? We will take help of the stone motion. Okay. And now we will calculate what is the time taken by a stone to reach the ground. What will be velocity of a stone when it reaches the ground? Please tell. Is this part clear?
Yes, sir.
So it means for the stone, if I apply the equation, what should I do it? The displacement, can I write it minus 50? Initial velocity plus 20. Time I have to calculate. Do we have the quadratic? 5t squared minus 20t minus 50 equal to 0. That gives us the t. So t squared minus 4t minus 10 equal to 0. So what is the time we are getting in this question? The time we got it minus of minus 4 plus minus b squared 16 minus 4 ac, that means 40 it will become, divided by 2. So 4 plus minus 56 means 4 root 4 and root 14 will be there na, right? 56 is there na, so 56 is there, so what we will get it? 4 4 so 2 root 14 by 2. So we have 2 plus root 14 and 2 minus root 14. Again, this is negative, not possible. This is the correct answer. Understood? So that is what we got it, time taken by the stone to reach the ground. What else can be asked in this question? Do you know? Sometimes they will ask you in this question, find the separation between the balloon and the stone when it reaches the ground. What does it mean? What will be the answer of this one? 50 meter. Tell me. What will be the answer? 50 meter will be answer or something else? Do you understand my question? My question is, find the distance between balloon and stone when stone reaches the ground. Can you tell me what will be the answer? Please tell, all of you. what will happen in this journey? Tell me. See, when the stone is in its own journey, is the balloon stopped or balloon keep on moving upward? So, if I ask you, what is the distance between stone and the balloon when it reaches the ground? Do I need to find out how much further this balloon has moved? Please tell me. How much further the balloon has moved? Is it what we have to calculate it? Please tell me. Understood this one? So that further distance I need to calculate it to solve this question further. Clear? So this is about the motion with uniform acceleration, motion under the gravity. The motion under gravity is a special case of uniformly accelerated motion. Now, if the motion is non-uniform, where acceleration is not constant, then we cannot apply these equations and we have to take help of what? Differentiation and integration. So let's see how do we use the differentiation and integration. Okay, please tell me. Position is given to us in the problem. Okay, so if I differentiate the position differentiate with respect to time, what I will get it? Can you tell me? Rate of change of position with respect to time, what does it represent? Does it represent the instantaneous velocity? Please tell me. If I differentiate position with respect to time, all of you there? Please
Yes,
tell
sir.
me.
Yes, sir.
Yes, sir.
No response. Please tell me, do you get it or not? What we discussed till now?
Got it, sir.
Yes, sir.
Okay. So if we have position versus position as a function of time, and if we differentiate with respect to time, what we will get it? We will get the velocity. And if we differentiate velocity with respect to time, then what we will get it? If we differentiate velocity with respect to time, what we will get it? We will get the differentiation always gives us what? Instantaneous value. Is that clear? Please tell me. So from the position, if I want to know the velocity, what we will do it? Dx by dt. If we want to know the acceleration, what we should do it? dv by dt. So if velocity is given as a function of time, its a differentiation with respect to time gives us acceleration. There is another way I can find out the acceleration, and what is that? See, can I write acceleration as dv by dt? Can I write dv by dx into dx by dt? Please tell me. Did I write the same thing or different? Please tell me. Acceleration was there. I wrote it as dv by dx into dx by dt. Is it the same thing written or something different is written?
Same thing.
Same thing. But what is the
V,
advantage of
V,
that? Yes, the advantage of this one is what? This dx by dt is also velocity. So can I also use it? Well, acceleration can be written as v dv by dx also. So tell me when I should use it dv by dt and when I should use it v dv by dx. So that depends in the question whether velocity as a function of time given or velocity as a function of position given. If velocity as a function of time given, we will use it dv by dt. If velocity as a function of position given, we will use v dv by dx. Is that clear? Please tell me. Is this part is clear? So this
yes,
is the
sir.
difference. Velocity we get it rate of change of position. Acceleration we got it. Either we will use it dv by dt or we will use it v dv by dx depending on the question whether velocity as a function of time given or velocity as a function of position given. This is about the differentiation. Now, integration, what it is? It is just opposite of the differentiation, isn't it? See that. What is the acceleration we have? dv by dt. So can I send it here? Acceleration dt one side and dv other side? Please tell me. Acceleration A we have. What we did? We sent the dt one side and dv we are keeping it other side. And then we are going to do integrate it both the side. So A dt equal to dv can be written. So now if you integrate it, are you getting integration of A dt equal to dv? So what is the acceleration function dt integration will give us? Is it going to give us the change in velocity? Please tell me. Not velocity, change in velocity. Be careful about that. Integration of acceleration with respect to time gives us the change in velocity. If I have something like this, acceleration equal to v dv by dx. So if I integrate acceleration with dx, what we have other side? V dv integration. That is also an important one. Okay. So that directly doesn't give me the velocity. It gives us what? V dv integration will be what? V square by 2. So it doesn't give us directly change in velocity, but it is some way going to give us the change in velocity. Okay. Clear? Next one. What was the velocity we had? Dx by dt, right? So can I write it here again? V dt equal to dx. Let's integrate it. So please tell me, what is the v dt integration gives us? Dx integration means what? Final position minus initial position. So can I write it? V dt integration gives us change in position of the particle. What it gives us? Change in position of the particle. And do you know what is the change in position? Is it also called as the displacement of the particle? Please tell me. Is it also called as the displacement of the particle? Please tell. VDT integration. Does it give us the change in position? And change in position is also equal to what? The displacement of the particle. Please tell. Clear about this differentiation and integration thing? When we should use it? The moment acceleration become variable, never use the equation of motion. Always write the differentiation or integration. Please tell. Clear about this one?
Yes, sir.
Yes.
So now, if we know that what is the differentiation gives us, so that means can I also find out what is the slope of a graph gives us? Please tell me. Because sometimes they will give us the graph. Let's say there is a graph given to us, and this graph is based between position on x-axis, time on y-axis. Can you tell me what is the slope of this graph represent? Here the slope or here the slope. Can you tell me what is the slope of this graph represent? Is the slope of this graph represent dx by dt? Does this mean it is representing the instantaneous velocity? Means if I want to know the velocity at a particular instant, I should just find out the slope of the graph at that moment. So that's why position versus time graph slope gives us what? The velocity or instantaneous velocity. Next. Next graph is velocity versus time. Next graph is what? Velocity versus time. Can you tell me what is the slope of this graph is going to represent? Please tell. What are these slopes are going to represent? Is the slope is representing here velocity v, time t? Is the slope is representing dv by dt? So is the slope is giving me instantaneous acceleration, or instantaneous acceleration is just called as the acceleration? Whether you call it instantaneous acceleration or just acceleration, its a meaning is same. Clear? The position versus time graph slope gives us the velocity. The moment where you are calculating the slope, velocity at that moment. Same way, velocity versus time graph slope gives us what? The acceleration. And you will find sometime the graph will be given like this. Right now, I am not taking anything about the area. Whenever we get a graph, any graph has two important, uh, you can say the result, or you can say two important thing about the graph we have. One is the slope of the graph, and other one is the area made by the graph, right? So velocity versus position graph is there. Can you tell me what is the slope represents? What is the slope of this graph represent?
Acceleration.
Does it give us something important?
Yes, sir. Sir, it
What
does
does
not.
the slope of velocity
It does not give
represent?
us anything useful. We get dv by dx. It's
Okay. The slope, it does not give us anything meaningful. dv by dx. Yes, it is true. It's a slope is not giving us anything much meaningful. But you see, the moment I will multiply this slope with the velocity at that instant, will it become meaningful? The slope itself doesn't tell us anything clearly, but can I say slope multiplied by velocity at that moment, or velocity multiplied by slope at that moment? What is that? That is v into dv by dx na, and that is again what? An important thing. What is that? That is the acceleration. So sometimes directly the slope gives us something, sometimes directly it did not give us, but after some modification in the slope, I can get something meaningful, impactful thing. Please tell me, do you understand about how do we use the differentiation? Velocity
Yes,
we
sir.
want to find out rate of change of position. Acceleration, rate of change of velocity. But sometime velocity will be given as a function of position. In that situation, we should use v dv by dx to find out the acceleration. This is about the differentiation. Sometimes function is given to me. They are asking to find the slope, find the velocity, find the acceleration. Sometimes instead of giving you the function, they will give you the graph. And then what we have to do? From the graph, we have to find out what is the slope. Is that clear? Next, we have the integration thing. Again, integration, if you see that, acceleration versus time, or acceleration integration with respect to what? The time gives us what? The change in velocity. Keep in mind the word change in velocity. Acceleration integration with dx, that also gives us something meaningful, right? V final square by 2 minus V initial square by 2. And velocity integration with time, that gives us the change in position, which is also called as the displacement of the particle. Change in position is also called as the displacement. And same slope thing we are calculating using the area, sorry, using the graph also. So what we do next, next thing we have to discuss is, if functions are given to us, how do we find the velocity, acceleration with the help of differentiation and integration? Then after that, sometime they will give you the graph. And from the graph, how do we find the slope and area, that we are going to discuss. So next class, what we will do, we will finish it all of them, the graph part and uh, using the calculus part, and then we will go for the relative motion thing. Okay, relative motion in 1D. So please tell me, are you able to understand? Any doubt or confusion is there? Please tell me.
no, sir.
Please tell, clear about it, what we are discussing here?
Yes, sir.
Yes.
Okay, so now please solve the questions. Okay, kinematics in 1D, you can solve it everything except the graph part. Calculus questions, you can do it. It's not very difficult calculus question. But next class, I will just discuss 1-2 example on that so that it will become much more clear to you. Okay, so now from the thing is, all the exercise questions, single choice questions, please try to complete it. Okay. Please tell all of you.
Yes, sir.
So next class we will have it on Wednesday. Okay, Wednesday same time 8 p.m.
Okay, sir.
Tuesday we don't have the class, except that every day 8 p.m. we have the class. Okay, so let's join it on
Can you
Wednesday.
repeat, sir?
Only Tuesday. Tomorrow we don't have any class. Okay. Apart from that, every day
Yes,
8 to 9 we have the class, right?
okay, sir.
Right, everyone? Then good night. Take care.
Thank you, sir.